This is Algebra 2, Unit 10, Lesson 10, on polynomial long division. What we're going to look at in this lesson is dividing a polynomial by a binomial, so a two-term polynomial. All the multiplication division we have done so far has been just dividing by factoring, but sometimes if you just have a single term, you have to use what's called long division. So let's consider the division problem 1519 divided by 7. We're going to look at the process of long division with regular integers, and then we'll look at it comparing it to polynomials. All right, so if we have 1519 divided by 7, and we do it as long division, so we would put 1519 inside the division bar, or division symbol, the 7 on the outside. Then we go 7 goes into, doesn't go into 1, but it does go into 15 2 times. Multiply 2 times 7 is 14, and then we would subtract. 15 minus 14 is 1, and then repeat the process. Bring down the 1, 7 goes into 11 once, 1 times 7 is 7, do subtraction, 11 minus 7 is 4, bring down the 9, 7 goes into 49 7 times, and my remainder is 0. Okay, so what this is saying, 519 divided by 7 is 217. So as a multiplication equation, we could say that our divisor 7 times our quotient 217 is equal to 1519. All right, so that's what we learned back in 3rd or 4th grade doing long division. All right, now, what if we have 1522 divided by 7? And we're going to write the equation a plus rb form and a plus b plus c over c form. Basically, well, we'll explain it when I get to there. All right, so 7 goes into 1522. All right, same process. 7 times 2 is 14. Subtract. 15 minus 14 is 1. Bring down the 2. 7 goes into 12 once. Subtract. 1 times 7 is 7. 12 minus 7 is 5. And 7 goes into 52 7 times. 7 times 7 is 49. But then we have a remainder of 3. Okay, so back in 3rd or 4th grade, you probably learned this. So write your answer in a plus rb form. R would be the remainder. So this is going to be 217 plus a remainder of 3. Now, we could have also written it as a fraction. This would be 217 plus b over c form. So c would be your divisor. So it would be 217 plus 3 over 7, or 217 and 3/7. Okay, so that's what we learned back in 3rd or 4th grade. Now, for as an equivalent multiplication thing, we would say 7 times 217, and then we'd have to add the remainder of 3, will give me 1522. Remember, this is you have to add in the remainder. So this is what it looks like when we're doing the numbers. The process is the same when we do it with polynomials. All right, now, simplify. 2x squared plus 15x plus 18 divided by x plus 6 by performing polynomial long division. Now, what we've done so far is we usually factor and cancel. And that'll work if you can do it. But sometimes it won't work, or sometimes they may specifically ask you to do long division. But the process is still the same. We set it up as a long division problem. This is your divisor. This would go on the outside. And then you have 2x squared plus 15x plus 18. Okay, so what we have to do, what we did when we divide, we have to see how many times this goes into this. Now, we only want to look at the x and the 2x squared. Now, x times what will give you 2x squared? Well, it'll be 2x, and that would go up here. Now, I'm not worried about the 6. I'll worry about that later. When I put the number up here, I multiply this number by the divisor and put it down here. But remember, there's 2 terms here, so it has to distribute to both terms. So 2x times x is 2x squared. 2x times 6 is 12x. Okay, now, when I did numbers back here, once I got this number, what did I do? I subtracted. So remember, when you subtract, what do you have to do with a polynomial? You have to change all the signs. All right, what I like to do is I like to put the opposite sign down and circle it so I know I changed the signs. So 2x squared minus 2x squared is 0. 15x minus 12x is 3x. All right, what was my next step? I bring down the 18. All right, again, I'm only looking at the x and the first term of the polynomial. The second term will work out itself. So x times what gives me 3x? It will be 3. 3 times x is 3x. 3 times 6 is 18. And then I want to subtract. Make sure you change both signs. And this is going to equal 0. Okay, so simplified, this is going to be 2x plus 3. This equals 2x plus 3. So the result, what we're saying, is an equivalent multiplication equation, x plus 6, the divisor, times the quotient, 2x plus 3, should give me 2x squared plus 15x plus 18. Now again, we could have factored this and then canceled out the x plus 6, and that would have been fine. But this specifically said long division. Now, when do we use long division? Most of the time, when something has a remainder. So, we have 2x squared plus 15x plus 20 divided by x plus 6 in the form of this. Now notice this is r. R is a constant, and this is going to be the remainder. So, let's do the long division. X plus 6 goes on the outside. This goes on the inside. 2x squared plus 15x plus 20. All right, so again, we only look at this and that. All right, so x times what is 2x squared? It is 2x. Now, make sure you multiply the 2x, or whatever you put up here, by both of these terms. 2x times x is 2x squared. 2x times 6 is 12x. All right, my next step is to subtract. Remember, you're subtracting both of these terms, so I'm going to put a subtraction and a subtraction there. So that reminds me to do that. 2x squared minus 2x squared is 0. 15x minus 2x is 3x. Okay, now we're going to repeat the process. X goes into 3x. X times what is 3x? It'd be x times 3. All right, multiply both of these. 3 times x is 3x. 3 times 6 is 18. And then subtract. Make sure you subtract both terms. 3x minus 3x is 0. 20 minus 18 is 2. So this is my remainder. So when I write this as a term, my answer is going to be 2x plus 3 plus, write this as a remainder over the divisor. The remainder is 2 over x plus 6. Okay, so as an equivalent multiplication equation, what we are saying is if you take x plus 6 and multiply it by 2x plus 3 and then add in 2, which was my remainder, I will get 2x squared plus 15x plus 20. All right, it's a little confusing because we're using polynomials, but the process is still the same as regular long division. Just think of your steps as you go. So when we divide two polynomials, we always get another polynomial and a remainder. If there is no remainder, your remainder is 0, of course. This is known as writing the rational expression in quotient remainder form. All right, so write each of the following rational expressions in the form q of x plus r over x minus a form. Basically, this is going to be your remainder, and this is your quotient, and this is your divisor. Okay, so that's what all those things stand for. All right, so when we divide this, x minus 3 goes on the outside, x squared plus 2x minus 5 goes on the inside. All right, so remember, all we want to look at is this term and this term. X times what gives you x squared? It would be x. All right, multiply the x by both terms of the divisor. X times x is x squared. X times negative 3 is negative 3x. Okay, now, subtract would be my next step. Now, when you subtract, you change the signs of both polynomials. So I'm going to change this to minus, and I'm going to circle it so I know I did it. Now, this is already minus, so what's this actually going to become? It's actually going to be 2 minus minus 3, so this is actually going to be 2 plus 3. And that's going to give me 5x, because this cancels out. Bring down the minus 5. X times what gives you 5x? It'd be plus 5. All right, multiply both terms. 5 times x is 5x. 5 times negative 3 is negative 15. All right, when you subtract, change the signs. Minus, this becomes plus. So negative 5 plus 15 is 10. So your final answer should be x plus 5 plus remainder of 10 over the divisor. Write it as a fraction, 10 over x minus 3. And that's your answer. Okay, little tricky because, like I said, most of the polynomials, but take it step by step. Don't try to do 3 things at once. All right, let's try this one. 2x squared minus 23x plus 17 divided by x minus 10. The divisor x minus 10 goes on the outside. 2x squared minus 23x plus 17 goes on the inside. Again, look only at the first term here and here. X times what is 2x squared? Well, x times 2x is 2x squared. Multiply both terms by 2x. 2x times x is 2x squared. 2x times negative 10 is negative 20x. All right, we're going to subtract, so we have to change the signs. This is going to become minus. This is going to become plus because it was already minus. Add down your columns now. These are going to cancel. Negative 23 plus 20 is negative 3x plus 17. All right, so x times what gives you negative 3x? It would be negative 3. Multiply both terms. Watch your signs. Negative 3 times x is negative 3x. Negative 3 times negative 10 is positive 30. All right, now we have to subtract. Change this to addition. Change this to subtraction. 17 minus 30 is negative 13. All right, and that's as far as we can go. So my final answer will be 2x minus 3, my quotient, plus the remainder, which is negative 13, over the divisor, x minus 10. You may also see this as 2x minus 3 minus 13 over x minus 10. That's the same thing. We just made this plus negative. Okay. Now sometimes we can use the structure of an expression instead of using polynomial long division. Consider the expression x plus 8 over x plus 3. We would want to write it as a plus b over x plus 3. So if I want to write the numerator as an equivalent expression involving x plus 3, how is x plus 8 written as x plus 3? Well, wouldn't it be x plus 3 plus 5 is equal to x plus 8? All right, and that's over x plus 3. Okay. So, if this is x plus 3 plus 5, use the facts that distributes over addition to write the final answer. I could rewrite this. Remember, this is over both terms, x plus 3. I could write x plus 3 over x plus 3 plus 5 over x plus 3. What's x plus 3 over x plus 3? It's equal to 1. 1 plus 5 over x plus 3. All right, so if I wanted to write this, I just have to split this up, make this into a 1, and then put the remainder as well. All right, now we can extend what we did in the last problem to more challenging structure problems. Let's save these and we'll look at these in the next class.